Hey mathematicians, here are your notes for 3.7, where we're going to be talking about percent of change. So to start off, I want you to fill out this what I think it is section of the table, and then when you're done with that, come on back and we'll go through it together. Alright, hopefully you had time to fill out the what I think portion of the table. Now we're going to jump into what I know it is. If we're going to be able to calculate the percent of change, we need to first off know what is percent of change. Well, the percent of change is just the difference, as in an increase or decrease in the amount of something, expressed as a percent. So essentially, the change of something as a percent. And I know that doesn't really help, and I know we're not supposed to use the actual words in the definition, but you'll see why this makes sense in just a minute. It makes sense then that if the new number is greater than the original number, the percent of change is increase. So new greater than original, that would be a percent of increase. If new is less than the original, that would be a decrease. So let's look at some examples of this. That might help us understand those definitions a little bit more. At the end of the 2010-11 school year, there were 478 students at PHS. At the beginning of the 2013-14 school year, there were 430 students. What is the percent of change? Who might want to know, there should be a comma here, who might want to know this and why? Well, let's just find out what the percent of change is. I'm going to write down my information here just to help me out. New and original. My original number was 478. My new number is 430. Right off the bat, I should be able to recognize whether or not this is an increase or decrease. Notice when we went from original to new, it got smaller. Based on our table up here, that would be a decrease. In order to find the percentage or the percent of decrease, we're going to use this formula. New minus original divided by the original. And if you have a note card somewhere nearby, and this would be something I would suggest putting on that. So using this, our new is 430 minus our original is 478 divided by 478. We calculate that to be 48 divided by 478, and that shows us that it's approximately a 10% decrease. So let's put that over here. Now, who might want to know this and why? Why do we care about this decrease? Why is this problem even on this page? Well, the first thing we should notice is if we have a decrease in students, that right away tells us that there's less students in the district, which affects how many staff members we need, how many lunches are being served, how much money is needed in the district in order to serve those students, etc., etc., etc. There's a lot of different reasons why we might want to know something like this. Let's see another one. The field used by the National Football League is 120 yards long, including the end zones. The length of the field used by the Canadian Football League is 25% longer than the one used by the NFL. So what is the length of the field used by the CFL? Well, right off the bat, I can't put a new and original down because neither one of them is necessarily new. However, I right away know that I have an increase from the NFL to the CFL because it tells me that it's 25% longer. So if the NFL is 120 yards long, I need to know what a 25% increase would be to the CFL. Now I could set up another fraction like this, but I'm actually going to take the easy way out. I know that if it's an increase of 25%, that's the full 100% of the original plus 25% of it. 120 of, meaning times, that. So 100 plus 25%. When I calculate that, I notice that I'm going to get about 150 yards. Actually, it's going to be exactly that. So 100% plus 25% gives me an increase of 25%, or 150 total yards. So now, let's represent that using math. Both of these methods, totally viable, but let's look at them with just numbers. Let's practice a little bit more without that context. So find the percent of increase or decrease given the following. If your original is 90 and your new is 30, you right off the bat should be able to tell me that that is a decrease. Now let's use that formula from before. New minus original divided by original. Plug some numbers in. 30 minus 90 divided by 90. This is going to get me negative 60 over 90, but in this case, that negative doesn't really matter because all it's really doing is reinforcing that we have a decrease. If it was a positive number, it would be an increase. So when we get 60 over 90, that's an approximately 67% decrease. All right, I would like you to try this next one on your own. Once you think you've set it up and calculated, come on back and we'll check it together. All right, hopefully you had time to check that, to try that one. Let's check it together. If we set our ratio up to be new minus original divided by original, we get 270 minus 90 divided by 90. And when we calculate this, we get 180 over 90, which is 2. Move the decimal place 2 to the right, and you get approximately 200% increase. Notice this one, when I subtracted up here, I got a positive number. That immediately tells me increase, but I can also reaffirm that based on the fact that my new is larger than my original. All right, let's jump to the back here. A coat is on sale for 25% off the original price. If the original price of the coat is $75, what is the discounted price? Go ahead and give that one a try. If you get done, go ahead and try the harder problem as well. All right. So a coat is on sale for 25% off of the original price. So in other words, if $75 is 100%, the percentage we're looking for is 75% of the original price because we got 25% off, but that means we're still paying 75%. So I could say what is 75% of 75, or 75 times 0.75. This says what is the portion I'm paying, not what is the portion I got off. If I calculate that, I see that I'm paying approximately $56.25. Not too bad, just a little bit of math gymnastics. But let's look at this next one. There's already, you can see this is a large problem, but that's okay. Renting a car can be a challenging experience. To rent a car in Milwaukee this week, the daily fee is $48.18. And I'm going to start kind of color coding things here. An 11.11% concession recoup fee is then added to the price. After that fee, notice after that fee is added, an additional 5% state rental fee is applied. Then a 3% local exposition tax is applied. And finally, a 5.5% sales tax is piled on. What is the final price of the car? And then I gave you a little hint here, and I said, make sure you are applying the fee or tax consecutively, not concurrently. So consecutively means we have to apply each one and then apply the new percentage to the new number. So I can't just add all of these up and then say, oh, he paid like a 15% increase. No, we have to do them individually. So let's go ahead and do that. 4818, it says an 11.11 concession recoup fee is added. So that means that I have to pay 11% on top of it. So I'm going to say, if I'm paying 100% of the original price plus that 11%, what I have to calculate it as when I put it in here, the same way that I said this was 0.75, let me scroll. I'm paying 100% and 11.11%. So this is the decimal version of 11.11% with the original price added. So when I calculate that, I get $53.53. Now I have to take the next fee. It says after that fee is added, an additional 5% is applied. So I'm going to take $53.53. I'm paying 100% of that amount and 5% on top of that 100. Remember that 100% written as a decimal is 1.0. Just keep that in the back of your mind. It's a really useful fact. All right, once I've calculated that, I see that I pay $56.21. However, I'm not done. I did the 5%. Now we have to do that 3%. Same thing. I'm paying 100% of that total plus 3% of it. Calculate that to be $57.90. And then finally, we have that 5.5%. $57.90. I'm paying 100% of that total plus the 0.55 tax. Remember to go from any percentage to a decimal. You're just going to move that decimal place 2 places. So 5.5% as a decimal would be 0.055. All right, final total comes to $61.08. There's no other tax we have to calculate, so our final price is $61.08. That last one can be a little tricky, and I know sometimes this piece is confusing for why I am multiplying by 1.11.11. You can also do this by multiplying that 48.18 times the 11% by itself and then adding that 41.18 back. I just think this is a little bit faster because it takes that original price into account by just multiplying by 1 out in front. Anyway, if you have any questions on this example or any of the others I've gone over, please don't hesitate to let me know.